Hey everyone! Welcome back to another exciting session of physics. Here's a fun thought. Have you ever stared at a melting ice cube and wondered, why doesn't the temperature rise while it's melting? Or why does your boiling kettle stay stuck at 100 degrees Celsius no matter how long it boils? Today, we are uncovering that mystery. It's called the change of state. Everything around you, the table you're sitting at, the juice you're drinking, and even the air you're breathing, exists in one of three states: solid, liquid, or gas. Now, when we add or remove heat, the molecules inside these substances either speed up or slow down, and that's what causes them to change their state. But here's the interesting twist: when a substance changes its state, the temperature doesn't change at all. That's because the energy being supplied isn't increasing molecular speed, it's being used to break or form molecular bonds. That hidden energy is called latent heat. We describe this mathematically as Q equals m multiplied by L, where Q is the heat energy in joules, m is the mass in kilograms, and L is the latent heat in joules per kilogram. So next time you see water boiling away or ice melting slowly, just smile, because physics is busy rearranging molecules, not just heating things up. Alright, picture this: it's winter and you're ice skating with your friends. You're gliding like a pro, and suddenly you realize, wait a minute, am I sliding on ice or on water? Yep, that's physics under your skates. Let's dive into melting, freezing, and the magical process called regelation. When a solid such as ice absorbs heat, its molecules vibrate faster until they break free from their fixed positions. That's when melting, or fusion, happens. The reverse process, where a liquid loses heat and becomes solid again, is called freezing. Both happen at a fixed temperature known as the melting point. Now, ice has a unique superpower. When you increase pressure, its melting point decreases. That's why, when a thin wire with heavy weights at its ends is placed over a block of ice, the wire slowly cuts through it. The pressure below the wire causes the ice to melt, and once the wire passes, the water refreezes. That's regelation, nature's slippery trick. And guess what? That's exactly how ice skating works. Your skates put pressure on the ice, creating a thin layer of water that helps you glide smoothly. So every time you skate, you're literally doing a mini thermodynamics experiment. Now let's turn up the heat, quite literally. Have you noticed that no matter how long you boil water, it refuses to go above 100 degrees Celsius? Or that cooking takes forever in hill stations? Let's boil down the reason: vaporization and boiling point. When we heat a liquid, its molecules get restless and move faster. At a certain temperature, the vapor pressure inside the liquid becomes equal to the external atmospheric pressure, and that's when boiling begins. The temperature at which this happens is called the boiling point. At sea level, water boils at exactly 100 degrees Celsius, but at higher altitudes like the Himalayas, where air pressure is lower, water boils at a lower temperature. That's why cooking takes longer. In contrast, in a pressure cooker, the pressure inside increases, so the boiling point rises and your food cooks faster. So the next time you hear that whistle in the kitchen, that's not just lunch, that's physics cooking up energy transformations. Okay, time for some show of solids, the ones that skip the liquid phase altogether. Ever seen dry ice in a party smoke machine? It turns from solid straight into fog. That's sublimation. Sublimation is the direct conversion of a solid into vapor without passing through the liquid state. Common examples are dry ice, which is solid carbon dioxide, and iodine crystals. They vanish into vapor like magic, but it's all physics. Now, let's talk about something even more amazing: the triple point. This is the one special condition where all three states of matter, solid, liquid, and gas, exist together in perfect balance. For water, the triple point occurs at a temperature of 273.16 Kelvin and a pressure of 6.11 multiplied by 10 to the power of -3 pascals. It's like the peace treaty of physics, the one point where all three states coexist in harmony. And believe it or not, scientists actually use this triple point of water to define the Kelvin temperature scale itself. Alright, time to crunch some numbers, and no, you won't need a calculator the size of a planet. Let's find the latent heat of fusion of ice. Here's our setup. 0.15 kilograms of ice at 0 degrees Celsius is mixed with 0.30 kilograms of water at 50 degrees Celsius. After mixing, the final temperature comes out to 6.7 degrees Celsius. We'll use our heat balance law. The heat lost by the warm water equals the heat gained by the ice and the resulting water. So, the equation looks like this. Open bracket 0.30 close bracket multiplied by open bracket 4186 close bracket multiplied by open bracket 50 minus 6.7 close bracket equals open bracket 0.15 close bracket multiplied by L plus open bracket 0.15 close bracket multiplied by open bracket 4186 close bracket multiplied by open bracket 6.7 minus 0 close bracket. When you solve this step by step, you get L equals 3.34 multiplied by 10 to the power of 5 joules per kilogram. That's the latent heat of fusion for ice, exactly matching experimental data. So that simple formula, Q equals M multiplied by L, tells us how much hidden energy is absorbed or released when matter changes its state. That's not just math, that's molecular storytelling. So, to wrap it up, the change of state is one of physics' most beautiful stories of balance between energy and matter. When solids melt, liquids boil, or vapors condense, the temperature may stay constant, but the energy exchange is monumental. The latent heat, symbol L, represents how much heat per kilogram is needed for the transformation, while pressure, symbol P, and temperature, symbol T, control when and how it happens. Whether it's ice melting on a road, steam rising from your cup of coffee, or clouds forming in the sky, the same rule whispers through all of it. Q equals M multiplied by L, energy is never lost, only transformed. So remember, every snowflake, every boiling kettle, every misty morning is physics in action. I hope this session melted your confusion, boiled your curiosity, and sublimed your boredom. See you in the next class, where we'll heat things up again, the scientific way.